Alright, so we're gonna build the vehicle. I have Tech to Win running. Let's see, we have a 2005 light duty GMC truck. It's 4-wheel drive. We're gonna look at powertrain, check engine lights on. It's got the L59 in it. This is the alt fuels vehicle, or flex fuel vehicle, I should say. Automatic transfer case with traction control. We're going to pull codes. Okay, so we have oxygen sensor bank 1, sensor 1 failed current. Fuel trim lean bank 1 failed current. Engine misfire detected failed current. And that first code that we saw, the ECT sensor high voltage, this was because I had the coolant temperature sensor unplugged. So we're actually good. This is not a current code. It's something that I induced. O2 sensors are pretty much coming online now. We can see our short-term fuel trim is starting to climb. And bank 1 sensor 1 is starting to drop into an extreme lean condition. Bank 2 sensor 1 is ranging normally. And we can see our fuel trims here are destroyed on bank 1. We're trying to add so much fuel right now, it's not even funny. This one is still showing a little bit, it's trying to take fuel away. Look, we're bank 1 sensor 1, we're stuck less than 40 most of the time. This truck has already gotten plugs and wires, not because I thought that it was going to fix it, but because the plugs that were in there, particularly bank 1, so cylinders 1, 3, 5, and 7, were showing carbon fouling. Showing extremely rich mixture. And we can see as I scroll down a little bit more, we got short-term fuel train bank 1 is at 26, long-term is at 25. It's adding as much fuel as it possibly can to bank 1. While bank 2, it's taking a little bit of fuel away, and the long-term is kind of suffering as a result. But like I said, I think we need to concentrate on bank 1 sensor 1 oxygen sensor and see what happens with it. So I noticed this, key on, engine off. We have bank 1 sensor 1 O2 sensor is showing super rich, off the chart rich. 900 is like normal operating rich. Well, I guess if it was sitting at 900, it wouldn't be normal, but it's typical to see it ranging to about as high as 900. But this is key on, engine off, and we're at 1100. Contrast is bank 2 sensor 1, we're at 447, which is matching both downstream oxygen sensors. So this is the one that we need to take a look at. Okay, so I pulled both oxygen sensors out, both upstream oxygen sensors. The one on the left is the bank 1 sensor 1 oxygen sensor, and the one on the right is bank 2 sensor 1. Now, first thing you see is that, well, obviously bank 1 sensor 1 is completely covered in soot or carbon from over excessive fueling. Our fuel mixture is way too rich on this side, which kind of contradicts what we were seeing in the data stream, because the data stream says we're running so lean that the converter should be glowing red and setting the car on fire. The sensor on the right, however, shows a relatively normal amount of wear on it. So I think what we're going to do right now is I'm going to switch bank 1 sensor 1 with bank 1 sensor 2, or excuse me, bank 1 sensor 1 and bank 2 sensor 1. So I'm essentially switching the two oxygen sensors on what bank they're reading from. And then we're going to see if what I'm suspecting, this sensor is always going to show lean once it's running. So it's going to show bank 2 sensor 1. That fuel trim is going to be super lean. It's going to start dumping fuel. Bank 1 sensor 1, when I put this one in there, is going to return to normal. Okay, so just as I suspected, I swapped bank 1 sensor 1 with bank 2 sensor 1, reinstalled them, and bank 2 sensor 1 now shows 1100 millivolts, which is exactly what that sensor was doing when it was in bank 1 sensor 1 position. So it looks like we have a contaminated oxygen sensor. So this is one of the ways that you would diagnose a failed sensor. When we talk about procedures such as formulate your own diagnostic plan, a lot of times that's based on experience, seeing what information is being presented to you. In this case, the sensor information looks wrong, and it can't be, engine's off, it cannot be producing this much fuel in the exhaust when the engine's not running. Okay, so we can tell just by the information presented that this sensor has to have a problem. Not 100% of the time it's going to have a problem, but I would say probably 90-95% of the time you see an oxygen sensor that tells you this, it's lying to you.
You underestimate the power of the dark side.
Okay. Most of the diag for this is going to be circuit testing and stuff like that. And this O2 sensor, because it is reading, it's reading incorrectly, but it is reading, it's more than likely going to pass the diagnostic procedures. I mean, other than telling you that, hey, your fuel trim, your fuel mixture is really rich, which in this case is a lie, and when it's running, it's really lean, which in this case is also a lie. So you have to be able to determine, looking at the data, that this data is not correct, it doesn't make any sense. What do I need to do to diagnose this? And because we have another sensor that we know is reading good, because we don't have a problem with that cylinder, with that bank, if we swap the two and the problem follows, then we know that it's the sensor, not the engine. Okay, so we got the sensor swapped. Bank 1 sensor 1 is now in bank 2 sensor 1, and bank 2 sensor 1 is now in bank 1 sensor 1. And it looks like we're starting to read the exact same way. Bank 2 sensor 1, and our fuel trims are starting to change. Our long term on bank 2 is starting to climb all the way up. Short term on bank 2 is all the way up. And bank 1 long and short term is starting to mirror what it was doing when bank 1 sensor 1 oxygen sensor was in bank 1.